Hello, am I audible?
Yes, sir.
Okay. So number two is homework. Is it okay for you? What is number two? F is nilpotent if and only if A0 to AN are nilpotent in R. Anyone has done this problem? Suppose suppose F is nilpotent. Then what happened? Again consider the map pi. Let P belongs to speaker. We consider the map R2 R mod Px A0 plus an x to the power n goes to. I should write here B0 because A is special. So I should write here B0 M. Same map. Then if is nilpotent, sorry, Rx, not R, it is Rx. So what I have right, so this is Rx, right? Here it is wrong. Rx. See the domain. So F is nilpotent implies pi F is nilpotent. F to the power k equals to 0 imply pi F to the power k equals to 0 pi F whole to the power k, because it is ring homomorphism, it is 0. But R mod P is an integral domain this imply R mod Px is an integral domain. This imply pi f equals to 0 because 0 is only nilpotent element in an integral domain. See, pi f to the power k is 0 and it is integral domain, so pi f is 0. Therefore a0 plus p, what is pi f? 0. So ai plus p equals to 0 plus p for all I. This implies ai belongs to p. Since p is chosen arbitrarily, this implies intersection p spec r, that is equals to nil radical of r. This implies ai are nilpotent. Conversely, suppose if ai are nilpotent for 0 less or equals to I less or equals to n, this implies ai x to the power I are nilpotent for in where rx, because if ai to the power li is 0, ai to the power li is 0, so ai x to the power I to the power li is what happened, ai to the power li commutative ring xi to the power li is 0. Since nil radical is an ideal, so sum also 0. Sorry, not sum 0. Sum also belongs to nil radical. So I should write here. I should write ai belongs to nil rx for 0 less or equals to I less or equals to n. Now it is ideal, therefore ai x to the power I summation I equals to 0 to n belongs to nil rx. This is nilpotent rx. Now question, can you generalize this for several variables rxy, for at first two variables for rxy. Next, here I have defined Jacobson radical fact. So someone, Rahul, has sent me a proof for for this fact, x belongs to Jack R if and only if 1 minus xy belongs to Jacobson is unit for all y belongs to R. So
No, sir, not me. I think someone else.
oh, who sent
স্যার
this
আমি
proof?
I think.
পাঠিয়েছিলাম
তোমার নাম কি?
লোপামুদ্রা দত্ত।
Lopamudra has sent this proof. I don't know. So I am writing her proof. Okay. What happened? Let X belongs to Jacobson radical R. I am exactly writing her proof equals to intersection of M spec R. So if there exists y belongs to R such that 1 minus xy is not unit R. So then there exists M belongs to max spec R such that 1 minus xy belongs to M. Again, x belongs to M implies xy belongs to M. Xy belongs to M. This implies 1 minus xy. X belongs to Jacker means x belongs to M. Okay. I should write here there exists M0 particular ideal. So it is 1 minus xy plus xy belongs to M0. This implies 1 belongs to M0. Contradiction. Hence 1 minus xy is unit for all y belongs to R. Conversely, if x does not belongs to Jack R, so there exists M0 belongs to max spec R such that x does not contain in M0. This implies M0 plus x generated ideal equals to R. And M0 is maximal ideal. Because M0 is strictly contained in M0 plus x generated ideal, maximal ideal. So what happened? 1 belongs to M0 plus x. So this implies 1 equals to some a0 plus xy for some a0 belongs to m0 and y belongs to r. This implies 1 minus xy uh,
Just a minute, I'm just interrupting a bit. God remains dead. I mean, is that Abhishek, right?
yes.
No, no, actually I'm taking an attendance, so just এক মিনিট দাদা, এক মিনিট। এই গড রিমেন্স ডেটটা অভিষেক তো?
হ্যাঁ হ্যাঁ হ্যাঁ।
বুঝেছি, তুই ছাড়া আর কে হবে? ঠিক আছে, ঠিক আছে, হ্যাঁ দাদা, সরি, মানে চালাও।
belongs to M0, this imply 1 minus xy is not unit for some y belongs to R. So we have done this proof. Okay. Now question is what 23. Let R be a ring. Ring means commutative ring with identity. F belongs to Jack Rx. Then 1 minus Fg is unit for all G belongs to, I should write if and only. For all G belongs to Rx. In particular, if F belongs to Jack Rx, then 1 minus xf is unit taking g equals to x. Let f equals to a0, a1x, an x to the power n. 1 minus xf 1 minus a0x, I should write here 1 minus a0x minus a1x square minus a n x to the power n plus 1. Now this fellow is unit if and only if what is the criteria of unit? Constant term, that means 0 degree term is unit and a1 a2 an are nilpotent. So here 0 degree term is 1, it is unit. Is unit this imply a0 are nilpotent. Okay, so what we have seen, f belongs to Jack R if a0 to ar an is nilpotent. That means if now see what is the criteria for nilpotent, a0 to an are nilpotent if and only if criteria. So f
is nilpotent.
F is nilpotent. So Jack Rx is subset of nil Rx. And this relation holds trivially, the Jack R is subset of nil R. Nil R is subset of Jack R. So in this case they are equal. So Jacobson radical of Rx is exactly equal to the nil radical of Rx. Okay. One, 1 minute, just 1 minute. ওই এখানে রেকর্ডিং চলছে, কি জানে এবারে জানি। এই তুই আবার উগুল ভেঙাস আমার। Hello. Okay. So we have proved that Jacobson radical is exactly equals to nil radical. Now, one of interesting result is result about maximal ideals. What are the maximal ideals of kx, cx, rx, where r is kx, ky, I think, ry, r is kx. This type of questions. Then cx, x is compact Hausdorff space, where cx is ring of continuous functions. So now we will focus on classification of maximal ideals, this type of questions. So let's study of this question. At first we will start with this compact Hausdorff space. Okay. Problem, I think all of you are familiar with this problem. X compact Hausdorff space. Cx the ring of all continuous function continuous real valued function. Okay. So what is the ring structure? Pointwise addition, pointwise multiplication. Now for each x belongs to x, define mx those f belongs to cx such that fx equals to 0 at that point. Claim max spec cx is mx such that x belongs to x. And the function theta is bijective. So this is the problem. So anyone can at first show me that mx is maximal ideal. How to show? Any approach? কেউ কি জানো কিভাবে এগোতে পারবো আমরা বা বলতে পারবে at least mx maximal ideal? তারপর আমরা দেখাবো যে অল ম্যাক্সিমাল আইডিয়াল গুলো এরকম দেখতে। ওকে, let us consider the function for each x belongs to x, define alpha x cx2 r f goes to fx. Clearly
Sorry, it goes to fx.
আচ্ছা, এটা কি অসুবিধা হচ্ছে? তাহলে আমি এই পয়েন্টটাকে একটু অন্য কিছু দিয়ে ডিনোট করি। a at the at I should write evaluation at that point. Okay.
Yes, sir.
Clearly alpha a is a ring, surjective ring homomorphism. Why? fg cx alpha a plus g equals to a plus g of a, but it is defined as fa plus ga. Alpha a fg a, it is a ring structure in cx, fa ga. and y is adjective. For each y
We can
belongs
take
to R,
scalar polynomial,
y
constant
belongs
polynomial.
to R, alpha a x minus a plus y equals to y, right? So it is a surjective ring homoorphs. Therefore, now what is kernel? Those f belongs to Cx such that fa equals to 0. In my notation it is ma, right?
Yes, sir. Yes.
Therefore, Cx quotient ma is isomorphic to R, but R is a field. This implies ma is a maximal ideal. Next we have to show that all maximal ideals are of this form. Let m belongs to max spec Cx. If m not equals to ma for all a belongs to x, if it is not look like ma type, then what happened? For each a, there exists fa such that fa of a not equals to 0, right?
Yes, sir.
Otherwise one small ma is subset of m, and by maximality they are same. Okay, if there exists some a such that at that point a all fa is if evaluated at a is 0 for all f belongs to m, then what happened? Ma is subset of capital M. Now they are both maximal ideal, so they are same. Okay. So okay. Now what happened? Since fa belongs to Cx, it is a continuous function. Is so there exists ua contained in a such that fa of x not equals to 0 for all x belongs to ua. So it is continuous, so there exists an open set. I should write open Now cover X union by UA. Since X is compact, there exists A1 AN belongs to X such that what happened? Such that X is equals to union I equals to 1 to N UAI. Right?
Yes, sir.
Consider F equals to F A1 square F AN square. রিয়েল নাম্বারে কি এমন পাওয়ার আছে যেটা কমপ্লেক্স নাম্বারে নেই? যেটা হলো সাম অফ স্কোয়ার ইজ সাম অফ স্কোয়ার ইজ জিরো ইমপ্লাইজ ইন্ডিভিজুয়াল জিরো। এটা রিয়েল নাম্বারে হবে, কমপ্লেক্স নাম্বারে হবে না। সো এখানে আমি রিয়েলের পাওয়ারটা ইউজ করছি। কনসিডার দিস ফাংশন। নাও লেট it is belongs to Cx because all are continuous, x2 are, so sum of square of continuous function is continuous. Let x belongs to x, then x belongs to u ai for some I, this imply f ai square x not equals to 0. This imply fx not equals to 0, because if fx 0 then sum of squared 0 is implies individual 0. Okay, so fx is not 0 for all x, so we can consider 1 by f belongs to, because f is continuous and nowhere 0, therefore 1 by f is also continuous. Now if ai belongs to m, see here fa belongs to m, right? So if ai belongs to m implies summation f ai square, that is f belongs to m. Now 1 by f into 1 by f belongs to cx, f belongs to m, that implies 1 belongs to m, contradiction. Therefore m equals to ma for sum a belongs to x. Hence max spec cx is of the form ma such that a belongs to x. Next question is theta is bijective. So all maximal ideal of the compact Hausdorff space of this form mx. Okay, this theta is bijective. How to show? Obviously theta is surjective, right? Because you have proved that any max spec cx is of the form mx, then consider this x. It is surjective, you have proved. What about injective? sorry, max specs, yes. Max spec. What about injective? Let x not equals to y. Apply Eurytion lemma. What is Eurytion lemma?
X is normal, there exists an G from X to uh, 0 1 close interval such that for any A and B close subset of X, A intersection B is equals to phi, then G of A is equals to 0 and G of B is equals to 1.
So top normal if and only if two disjoint closed set can be separated by continuous function, right? You have told this. So here compact Hausdorff, so a normal, okay. So what is Euryson lemma? Apply Euryson lemma. What can you say? Let x not equals to y in x. These are singleton closed set. So apply Euryson lemma. What can you say? It is x is Hausdorff, right?
There exists disjoint closed
Yes,
sets.
yes. X are closed in x. X is Hausdorff. Since x is compact, Hausdorff by the Eurytion's lemma, there exists fg belongs to cx such that what happened? Tell me.
Fx equals to 0, Fy
fx
equals to 1,
fx equals to 0, fy equals to 1. Good. I should
and
write.
Gx equals to 1.
Yes, yes, yes. Fy equals to 1, gx equals to 1, gy equals to 0, right? This implies f belongs to mx and f not belongs to my, and g belongs to my and g not belongs to mx, right? Therefore mx not equals to my. So x not equals to y if and only if mx not equals to my. You can say that. So theta is injective. Okay. Tell me if you have any question. Otherwise we will move to next part. কারো কোনো কোশ্চেন থাকলে জিজ্ঞেস করো। Okay. Should add another page. Next question, what are the ideals of direct product? আমি কি এটা করিয়েছিলাম? হ্যালো,
নো স্যার, ওই ভেক্টর
ওকে
স্পেস কিছু বলা হয়েছিল।
ওকে, let at first finite direct product, then infinite পরে করাচ্ছে। B rings consider and dot component wise addition, component wise multiplication. Then check that product n is a ring and identity element is it is ring. Now question is, one note that product ring is never integral domain. A product ring is never an integral domain. Okay, can you tell me that, can you give me an example of ring, local ring which is a product of some two sovereigns. At first, see that and I have to write there theta I should write R uh, RJ, I think, right? J R L position. It is an injective ring homomorphism. So RL is a subring of product ring Ri, is an injective ring homomorphism, and that is monomorphism. Ring and it is your projection there is
So theta I or theta L?
pi I, yeah,
Theta I or theta L?
theta I or theta L, I should write theta L. So xn, so here also I should write pi L, parity of notation for 1 lesser equals to L lesser equals to n. XL is a surjective ring homomorphism what is the kernel? What is kernel?
Kernel for pi L or theta L? Pi L. Yeah.
Or kernel pi.
So only 0 at the position of lth position and
That means
n minus 1. Yeah.
I can omit L because x1 xl 0 xl plus 1, sorry, L minus 1, L plus 1, so xn, so this is fixed only 0, so I can identify this with this ring. Okay, this singleton 0 only. Okay, now what are the ideals? My question is, what are the ideals of product ring? Then can we suppose R is local, can you give an example of local ring R such that R is isomorphic to R1 cross R2, where R1 R2 are uh, local do yeah, R1 R2 are subring of R. Okay, suppose R is local, R isomorphic to R1 cross R2, where R1 R2 are subring of R. Can you give an example? Can you give me an example? At first do the first question. What are the ideals of this? I should write product notation. Product notation. Claim ideals are of the form so ideals of the form product form. Okay, it is product form. How to prove? At first check that these type of things are ideal. It is easy to check. It is your check. If II are ideals, then N is also dual. It is the check. Next, any ideal of this form. How to show? Let J be now for each 1 lesser L lesser equals to N, pi L is a surjective ring homomorphism. It is a surjective, so extension of this, not extension, image of this is equals to extension, and hence it is ideal, right? If pi is surjective, then pi j is also ideal, right?
Yes, sir.
Hence J is subset of Ri and ideal for each trend. Let IL equals to pi Lj. Claim, or we want to show that J equals to IN. How to show? If x1 xn belongs to J, this implies pi L xn this simply xl belongs to, so x1 belongs to ns. This simply j is subset of let y1 in. Then what happened? So there exist A1L I should write here this type A1L, A2L. I should write double index A1L, NL belongs to product Ri such that ALL is YL for okay. Okay. Now how to show that this belongs to there? IL is ideal, J is ideal, right? I should write here J, pi LJ, right? I should write here J. So such that pi L of this is equals to YL and pi L of this is, I should write also some 1 minute. I should write such that pi L A1L ANL equals to ALL equals to YL belongs to IL. Okay, this belongs to J. So 0 0 0 1 0 lth position belongs to product of Ri. This implies J. This implies 0 0 0 ALL. This is lth position. Belongs to J. So this type belongs to J. This implies summation and this is I should write here YL. I should write here YL. Lth position belongs to J. L equals to 1 to N. What is this? Hence is subset of J. So from 1 and 2 we have J equals to ion. Next we want to know that what is spectrum of this and what is max spectrum of this product ring. Question: what is observation spectrum equals to union of, I should write here okay, I should write spec Ri. Okay, and this is disjoint. I should write disjoint union, not only union. I should write disjoint union. This disjoint union. Okay. Actually, or I should write in particular, any prime ideal of R1 are of the form all coordinates are 0, not 0, all coordinates of Ri and one coordinate is P. This type. Okay.
Same for the maximal, I guess.
Yes. Same thing is for maximal ideal. So my another question is it true for, I have done classification of ideals in product ring for finite case. Is it true for infinite case? মানে ইনফাইনাইট প্রোডাক্ট নিলেও কি এরকম আইডিয়ালগুলো এরকম দেখতে হবে? এটা হলো একটা কোশ্চেন।
কাউন্টেবিলিটি এখানে তো কোনো কাজে আসছে না সেভাবে।
আসছে, ভালো করে প্রুফ দেখো। ফাইনাইটনেস কাজে আমি লাগিয়েছি এখানে, প্রুফ ভালো করে দেখবে, পরের দিন আমাকে বলবে কোথায় কাজে লাগিয়েছি।
ওকে স্যার। হুম।
ওকে, প্রুফ খুব ইজি এগুলো। লেট কিউ belongs to spec R1, let Q equals to I1 cross by the previous problem, So R mod Q is isomorphic to this is check, এটা crucial check. Okay, now we have commented that এটা এখানে একটা কমেন্ট করেছি, প্রোডাক্ট রিং ইজ নেভার ইন্টিগ্রাল ডোমেন। কেন 0 0 1 for 2 R1 cross R2, what happened? R1 cross R2 0 1 1 0 0 0. Similarly for 1 to n, the product ring is never integral. So Q belongs to spectrum. So R mod Q, I should write here what is R. Let R equals to product ring of Ri. Okay, so R mod Q is integral domain, but if it is integral domain, then it should isomorphic to only one factor, মানে একটা ফ্যাক্টরই থাকবে আর বাদ বাকিগুলো জিরো হতে হবে।
Yes, sir.
Since এটা কি হলো? domain so this imply I should write R1 Rn. Since product ring is never a integral domain, also okay, I am not giving comment here. I should then write non-zero product ring, etc. IT equals to RT for not equals to L, and IL belongs to spec RL. So Q equals to R1 cross R minus 1 cross let IL equals to PL cross RL plus 1 So these are, if it is prime ideal, then it is of the form this. Conversely, for any PL belongs to spec RL, this is integral domain. Therefore, this fellow spectrum similarly we can say what is maximum spectrum. So we are identifying PL with this type. Then we can write actually, so we have disjoint union. Similarly, max spec disjoint union. Proof is similar, just you have to write field instead of integral domain. Okay, now I am stopping here. If you have any question, please ask me. কোনো কোশ্চেন থাকলে জিজ্ঞেস করো।
স্যার বলছি আগের দিন আপনি একটা নোট পড়িয়েছিলেন যে R/P যদি ইন্টিগ্রাল ডোমেন হয় R/Px টা ইন্টিগ্রাল ডোমেন হবে। তো এই প্রুফটা করার সময় আপনি এক জায়গায় ইউজ করেছিলেন যে পাই যে ক্যানোনিক্যাল ম্যাপটা নিয়েছিলেন ওখানে লিখেছিলেন যে পাই অফ এফ অফ এক্স ইজ আ ইউনিট ইন R/P অফ এক্স। আর আপনি রিজন দিয়েছিলেন যে ইন হোমোমরফিজম ইউনিট গোজ টু ইউনিট, কিন্তু ট্রিভিয়াল যদি নিই সেক্ষেত্রে এটা কি করে স্যাটিসফাই করবে?
ট্রিভিয়াল
যদি ট্রিভিয়াল কেস নিই তাহলে
ট্রিভিয়াল কেস মানে
মানে আমি বলতে চাইছি যে যদি আমি আহ, আপনি এই যে পয়েন্টটা বলেছেন না যে ইন হোমোমরফিজম ইউনিট গোজ টু ইউনিট,
হ্যাঁ,
হ্যাঁ এর প্রুফটা আমাকে একটু বলে দিন তাহলেই হবে।
এইখানে আমি লিখছি, এখানটায় ধরো এ থেকে বি এফ রিং হোমোমরফিজম আছে, আমি মুছে দেবো এটা আবার। হ্যাঁ,
আচ্ছা
ধরো এ ইউনিট, তাহলে এ ইউ ওয়ান, তাহলে এফ এ ইউ এফ ওয়ান, আমার রিং হোমোমরফিজমের ডেফিনেশন অনুসারে এটা ওয়ান বি এফ এ এফ ইউ। ঠিক আছে? তাহলে এ ইউ ইউনিট হলে
আচ্ছা।
এফ এটা ইউনিট, ঠিক আছে?
হুম।
আমি কোন সেট আপে পড়াচ্ছি সেটা কিন্তু ভালো করে দেখবে। আমার কাছে রিং, কমিউটেটিভ রিং উইথ আইডেন্টিটি আর হোমোমরফিজমে 1:1।
হ্যাঁ স্যার, এটাও একটা মানে প্রবলেম হচ্ছিল আমার। সেটা হচ্ছে আপনি যে রিং হোমোমরফিজমের ডেফিনেশনটা লিখেছিলেন, আপনি লিখেছিলেন ফাই ওয়ান এস ইকুয়ালস টু ওয়ান আর, মানে ওয়ান এস কে ওয়ান আর এ, সরি ওয়ান আর কে ওয়ান এস এ পাঠাচ্ছে। এবার যদি আমি জিরো রিং হোমোমরফিজম নিই তাহলে
আমি
ধরুন
ওটাকে আমরা রিং হোমোমরফিজম বলবোই না, বুঝেছো?
আচ্ছা।
আমার ডেফিনেশন অনুসারে ওটা রিং হোমোমরফিজমই নয়।
ওকে স্যার, ঠিক আছে।
আমি থিওরি কোথায়, আর এটা যথেষ্ট স্ট্যান্ডার্ড। মডার্ন অ্যালজেব্রা সবই এখন এই ডেফিনেশনেই চলছে, বুঝেছো? তুমি নাগাটার বই দেখো, আতিয়া ম্যাকডোনাল্ডের বই দেখো, মাতসুমোরা থেকে শুরু করে যে কোনো বই।
লেখা থাকে যে প্রত্যেকটা রিংকে আমরা কমিউটেটিভ রিং উইথ ইউনিটি অ্যাজিউম করছি, মানে দিয়ে কাজ করছি।
হুম।
Sir, how will we define disjoint union?
ভাই, ডিসজয়েন্ট ইউনিয়ন কীভাবে ডিফাইন করবে?
মহান মহারাজের ডেফিনেশন দিয়ে দাও, ডিসজয়েন্ট ইউনিয়ন ইজ ডিসজয়েন্ট ইউনিয়ন।
So,
ডিসজয়েন্ট ইউনিয়ন বেসিক্যালি ডিসজয়েন্ট
suppose
ইউনিয়ন।
A B set, A B set, it is set theoretic property, okay? A B sets, then A B subset of maybe some set of X, maybe, I don't know, or maybe two different set, I don't know. If A B subset of F, in in common sense A union B, there is some overlap, right? I should not write this type of picture, but what is disjoint union? A disjoint union B is denoted by, is actually A cross 0 union 1 cross B, or B cross 1, I think, right? B cross 1, union B cross 1. I am indexing this, so this is disjoint union, okay? If you have
Okay.
n times, then identify with n symbols.
0 to n. Yeah.
0 to n, so there is no overlap,
Yes, sir.
there is no overlap. অ্যালজেব্রিক টপোলজি করলে এগুলো ভালো করে পিকচার দেখানো যায়। এখন আমি অ্যালজেব্রা ক্লাসে কোনো পিকচার বলবো না, বুঝছো? এই তাহলে হাত
হ্যাঁ
নাড়া
স্যার,
শুরু হবে, আবার সমস্যায় পড়তে হবে।
এখানে তো স্যার হাত নাড়া বোঝাও যাবে না।
যাই হোক, ওকে, রাখছি।
হুম।